Here once again is our integration by parts formula. And so in the example I'm going to do in this video, I'm going to throw in two twists. Number one, we're going to see that we're going to have to apply integration by parts twice to get to our final answer. That shouldn't be too difficult. That shouldn't freak us out too much. The other interesting twist is that we're going to observe that, so here is our integration by parts formula. It's written out in terms of indefinite integrals. There's no bounds on the integrals here. But as it turns out, we can very easily change this so that this is now true for definite integrals as well. So if I say, what's the definite integral from a to b of u dv? So what you do, so this integral still has the same bounds, a to b. And then for the term that's u times v, you have to plug in the appropriate values of a and b there, just like you do usually when you're doing definite integrals. So without further ado, let's get on to an example. So I want us to evaluate the integral from 0 to pi of x squared cosine x dx. So earlier we were saying that, choose dv so that v is easy to calculate, choose u so that du is algebraically simpler. That's a pretty good first thing to think about here. So let's try u is x squared and dv is cosine x dx. So that says that du is going to equal 2x dx. And dv, we integrate cosine x. So v is sine x. And so this integral then is equal to u times v. So x squared times sine x minus the integral of v du, the integral of 2x sine x dx. But what am I missing here? I have not yet put on the bounds. So the bounds here is 0 to pi, so we have to put on the bounds here as 0 to pi. And also right here, have to evaluate this between 0 and pi. Now it's not too hard. Let's just do this calculation real quick here. This is pi squared times sine of pi minus 0 squared times sine of 0. And sine of 0 is 0. Of course, there's a 0 there already, and sine of pi is equal to 0. So this whole thing is equal to 0. So the only thing we have to worry about now is the integral from 0 to pi of 2x sine x dx. So let's go to a new slide for that. So the integral 0 to pi of x squared cosine x dx. Right now we know that's equal to minus 2 times integral from 0 to pi of x sine x dx. Hey, we've got x times a trig function. Let's try that for u and that for dv. So u is equal to x, dv is equal to sine x dx, du is equal to dx, v is equal to the integral of sine x is negative cosine x. And so all of this now, so minus 2 times uv, so that's x times minus cosine x minus the integral of v minus cosine x du. And that's dx. Once again, I haven't yet put on those bounds. So there's all the bounds that we need. And so I think at this point then, things here are pretty easy for us to evaluate. Okay, so first we plug in pi here. So that is x is pi times minus cosine pi. Cosine of pi is minus 1, so that's plus 1. Minus 0 times cosine 0 is 1. Who cares? That's just going to be 0. And then minus times minus is plus, so this is just the integral plus the integral from 0 to pi of cosine x dx. And so what do we have here? So minus 2 pi minus 0, or plus 0, who cares? It's a 0. And then the integral of cosine x is sine x. Evaluate that between 0 and pi. Both of those are going to be 0. And so our final answer here is minus 2 pi. So what's going on in this problem? Two things. Number one, realize that sometimes you have to use integration by parts more than once to get the answer that you're looking for. And the other thing is to realize that we can do integration by parts for definite integrals just like we can do integration by parts for indefinite integrals.